Hello everyone and welcome to another Leetcode question. So we'll be doing a Leetcode easy question, which is to remove linked list elements based on what is specified. So given the head of a linked list and an integer value, we have to remove all the nodes whereby the node's value is the same as the value, and then return the new head. So taking example 1, for example, it wants us to remove all the nodes with a value of 6. So that will mean that this will be gone, and this will be gone. So that's why eventually the output will be 1, 2, 3, 4, 5 like this. And for a trivial example where we are given an empty linked list, we simply return none. And for example 3, which is one of the examples that we have to take note of, whereby if you are given a linked list with all the values the same as the value right here, we simply return none, which is empty. So this will be split into two parts. So the first part, which I'll handle on top right here, is to find the new head. Okay, and second part is to traverse the rest and remove the same values. Okay, but what I will do first is to handle the first part about how we can find our new head. Okay, so for the new head, I guess it's relatively quite simple because at the start we can take it as we have a pointer initialized here that points to the head. Okay, and what it needs to do is that if the values is the same, right, then what I have to do is to shift my head over to look at the next element. So what I'll actually do is that I'll first have like what I mentioned just now, the head will be pointing to the 7. And while the values are the same, right, I'll simply change my current pointer to be the one at the next one. And I'll keep checking whether it's actually still the same value while my head is not none. So this will be how the algorithm will run. So it'll be something like while head is not none, check value. If same, look at next. So that will be how I actually find my new head. Okay, so let's take a look at an example whereby I actually have gotten my new head. So for this question, right, for this example, I'll still use the same example as 1. So with a value of 6, what I have to do is to actually remove all the nodes with a value of 6. So for the second part, we are already sure that this will be our new head. Okay, and usually for linked list questions, right, you can think, usually my first intuition is to think of using pointers. So what I will do in this case is to also use pointers as well. So I'll have a new pointer called current, which will point to the current new head, and I'll have another pointer called tail, which will point to the next of the current, which is actually which is the next of the current, if the next exists for the current. So that's a check that I have to make as well. Then what it will do is that for my tail, right, I'll be checking if the value is actually the same as the value right here. Okay, so if the value is actually not the same, right, all I need to do is just simply shift my current and tail one to the right so that I can continue looking at the next. So I'll shift this over so that my current will look at 2 and my tail will look at 6. And then now it will check, is my current value at the tail the same as the value that I want to remove? So if the value is the same, right, then what I will do is that I will simply shift over my tail to look at the next one. Okay, but at this point in time, my head will actually still remain. Okay, and I will eventually be breaking this connection right here also, where the 2 points to 6. And then now I take a look at the new tail, which has a node value of 3. So if 3 is the same value as 6, then that will mean that what I want to do is to establish the connection from 2 to point to 3, so that I can skip and remove this 6 right here. Okay, and after I form this connection, right, then my new current will be taking a look at the tail, at the tail that is valid. So it'll be like this. And then my other tail will now be pointing to the next one, right here. Because right now I want to see whether at this node my tail is valid or not. So this 4 right here. So we just continue to go down this line. So that will be how the general algorithm will work. So essentially, it's just to always keep checking my current and the tail. If the tail is valid, check current and tail. So if my current is valid and my tail is valid, then I can, if it's valid, then I can just skip to the right by 1 to check. Else, right, if my tail is not valid, the current will stay until I find a new proper tail. Okay, so that is why it's important. So that's how this algorithm will run. It's also important to take note that when you meet a tail that is invalid right here, we have to break off this connection because we also have to enter the edge case at the end. Like for example right here, whereby 6 is not valid, we have to break this connection so that eventually the one that points to 5 will be none. So that is why this breaking of connection is important. So now let's move on to the coding explanation. On to the coding part of the solution. So starting out with the pseudocode. First is to just do a basic check. If my head is none, so just a trivial check, right? If it's none, then I'll just return a none because it's trivial. And then the next part of the algorithm is to find a proper new head. And then finally, traverse through the remaining of the list. Okay, so let's just handle these parts one by one. So let's do the basic check first. So if my head is none, then just simply return none. Okay, it's quite simple. And now to find a proper new head. So now I'm mentioning this now, while my head is not none, then I check if my head's value is the same as the value right here. So if the same, right, my head needs to be, I have to check the next element of the head. Okay, and this will continue until I meet a valid head. So at a point in time, I can confirm that after this has run, my head will be valid. So what I'll do is to set a pointer to this new head. Because at the end of the day, I want to return this new head actually. Okay, so like what I mentioned just now, I have to traverse the remaining list. So I'll set up 2 new pointers also, the current and the tail. Current will be pointing to the new head at first, and my tail will be none. Okay, what I do is just initialize this as a variable outside first. So now I check if my current next exists. It's not none. Then I'll set my tail to the current next. Okay, so now I'll traverse through the list. So again, let's write some pseudocode first. So if while traversing, aka my tail is not none, my tail is not none, right? Then I'll check if my tail value is to be removed. Then I simply set the tail to be the next element and break connection with current. Okay? Else, I just continue. So I shift both current and tail by 1 to the right. So that will be how the general algorithm will run. Okay, so my tail is not none. I check. My tail's value is equal to the value. If so, I shift the tail to the next and break the connection. Else, right, what I will do is that I'll make my current next the tail, which means that it still remains the same, and my current will be set to the tail. After that, my tail will be tail.next, because I want to look at the next element. So after this whole algorithm is run, all we have to do is just simply return the new head. And I believe this should work. As for the time complexity, I believe it should be O of n, where n is the number of elements. Since like for edge case example right here, I have to check through the whole list and remove everything. For the space complexity, it will just simply be O of 1 because I'm not really using any extra space right here to run this algorithm. So yeah, I believe this should be the answer. this slight error right here, because previously for this part what I wrote is while head is not none, and if head value equals value, then I set it to the next. Okay, but actually this will not run properly and might even cause a time limit exceeded, because actually you should be checking this at the same clause, unless for the else part you add in a break, because if not you will not be able to proceed on and you get a time limit exceeded. So yeah, but I guess in essence it's much cleaner to be writing it like this. So yeah, just a slight error that I made. And also another thing we can take note is that we should just, if the new head we have is already none, we should just return none right here instead of going through the rest of the code. The solution is pretty okay, and if you have any questions then feel free to leave them in the comments down below. So thanks for watching and I'll see you again.